In this video, we are going to discuss object-oriented programming using Java. Of course, if you are using any other programming language like Python, JavaScript or C++, the concepts are likely to remain same. We shall also discuss the 4 pillars of OOPS concept and understand each with examples and exercise and solutions. Let's dive in. Java is an object-oriented programming language. Object-oriented programming paradigm is based on the concept of objects. Basically, everything around us can be defined as object with fields and methods. Say, an object dog can have fields like name, color, type, with some methods like eat, bark, or sleep. But where do objects come from? I'm glad you asked. Class. A class is a template or blueprint for an object. During runtime, objects are built using this template. For example, we can create a class called car with properties like brand, price, color, and some behaviors like auto drive or change color. Now, we can create objects of this class and access the properties and behaviors to create our own personal car. Imagine class as an object factory because now it can be used to create as many objects as we want with their own unique addresses. The 4 pillars or principles of object-oriented programming are encapsulation, inheritance, polymorphism, and abstraction. Let's understand each with real-world examples. Encapsulation is the mechanism of hiding of data implementation by restricting access to public methods. Data fields, also known as instance variables, are kept private and the accessor methods are made public to achieve this. Here we have created a car class with only one field, color. We set this field as a private string, meaning it won't be accessible to any other class. Now, we create a public getters and setters to allow access to this property. So when we create an object of car, we cannot directly access the variable color. Instead, we have to use the getters and setters. Here's a little exercise. Modify this car class to allow changing color only one time. Use your favorite IDE or any other online alternative you like. Go ahead, pause the video, try it out now. Define a private instance variable called change count. Set it to 0. When change color is called, increase change count by 1. Before changing color, check if change count is less than 1, else display proper message. Encapsulation also adds to security. Say in our previous example, we remove the getters and setters and allow open access to the property color. Then we cannot really track the change count for colors. User can use the change color method at first, and when they are restricted not to change more than once, they can simply use this loophole to set any color they want. Thanks for watching. Hit like if you loved the content. Consider subscribing if you want. Do not forget to press the bell icon for the next part of this video where we shall discuss abstraction, inheritance, and polymorphism.